Alright, now we're new chi-squared two-way test, but we're going to look at test of independence. First, we're going to review doing test of homogeneity. In a study of television viewing habits of children, we selected 300 first graders, 100 boys, 200 girls. Each child is asked which of the following TV programs they like best: The Lone Ranger, Sesame Street, or The Simpsons. Results are below. Do the boys' preferences for the TV program differ significantly from the girls' preferences? Use a level significance of 0.05. So, first thing we need to figure out is, how can we tell if it's a test of independence or a test of homogeneity? So, we're going to get this handout. Remember, goodness of fit, H0 is the specified distribution of the category variable is correct, or P1 equals P2 equals blah blah blah. Or the alternate would be the specified distribution is not correct, or at least one of the proportions is incorrect. Chi-square test for homogeneity, there is no difference in the distribution of a category variable for several populations, and that's the key. Several populations. Test of independence is really just one thing, and it's asking if two variables are related. Notice that this and this are the same. The conditions are the same. The only difference is our hypotheses and then our conclusion. So it all boils down to, if the data comes from two or more independent random samples, then do a chi-square test for homogeneity. If the data come from a single random sample, then do a test of independence. If you don't remember which, just put chi-squared two-way test on the AP test. Alright, so let's get back to our problem here. We're dealing with two different populations here, 100 boys and 200 girls, so this is a test of homogeneity. So our null is there's no difference in the distribution of boys and girls in viewing preference. Our alternate, there is a difference in the distribution of boys and girls viewing preference. So random, it said it clearly 300 is less than 10% of all children. All expected counts greater than 5. Well, we don't know yet. This is chi-squared test of homogeneity. Now we need to run our test. So we need to get into our matrices. We want a 2 by 3. They gave us the totals. They gave us a lot more than we need. So, second matrix, over to edit. And we don't need a 2 by 4. We need a 2 by 3 now. And we type in our new data. So 50, 30, 20, 50, 80, 70. So now we have our matrix in. Second quit. Clear all that junk. Stat. Over to test. And we're still doing chi-squared test. Calculate. There's our chi-squared, our p-value. That's not 6. At 6.3 times 10 to the negative fifth, so it's pretty much 0. Degrees of freedom, 2. Very low degree of freedom. That's fine. Let's make sure our expected counts were what they should be. So we go back to our matrix, and we look at matrix B. Hit enter. 33, 66, 36, 73, 30, and 60. They're all over 5. If we're doing this here, again, we go to this button to get the menu, the 3 by 3, but we want to change it to be 2 by 3. So 50, 30, 20, 50, 80, 70. And again, we want to store that. So control var gives us a little arrow, and we'll store it in as B. Then menu, statistics, and we're doing our chi-squared two-way test, of course. Observe matrix B this case. There's our chi-squared, the same p-value. Again, if we want to make sure that our expected counts are what they should be, var expected matrix Same ones we had before. So they're right. So, yep, we met our conditions. Chi-squared test of homogeneity because it's two groups. Chi-squared value of 19.3182, p-value that, or you can put approximately 0. It's pretty close. So we reject. So we have sufficient evidence to reject the null. Ergo, we can support the claim there is a difference in the distribution of boys and girls and viewing preference based on our sample at alpha equals 0.05. We just went with the alternate. Now here, it's different. It's one group. They took us one survey, and there's not different groups. There's not men and women. There's not whatever. We put one big group into all of this. So we're doing a test of independence. So the null and alternate are much, much easier. The null for independence is two categorical variables are independent, and two categorical variables are not independent. Or you can say there's no association. But the null is that they're not related at all. The alternate is that they are related somehow. Oops. So here we got a 3 by 4, so we got a lot of data to put in, but we do our hypothesis first. Marital status and happiness are independent. Very simple, very straightforward. Alternates, marital status, and happiness are not independent, or you could put dependent. Randomness is assumed. We didn't get a whole lot of information in the problem. Clearly, 2,985 people is less than 10% of all people. That's what this whole table adds up to. All expected counts greater than 5, well, we got to check. And we're doing a chi-squared test of independence here. But we do it the same way that we do a test of homogeneity. So, we go back into our matrix. We go back into A. I guess we could do different letters, but doesn't matter. And we have a 3 by 4, a little bit bigger matrix. So we put in our numbers, 600, 63, whoops, 600, 63, 1112, 144, 720, 142, 355, 459, 93, 51, 119, 127. Oops. So we put in the matrix just the same way, and we find the expected counts the same way. Row total times column total over total total, but we don't have to do that by hand, so we're not going to. So exit out of there. We're going to go to stat, run our test, our chi-squared test. So everything's the same. We don't do anything different. Chi-squared of 224, pretty big chi-squared value. Our p-value then is very, very small. It's 1.37 times 10 to the negative 45th. So it's pretty much 0. We do it on the Inspire. Same thing. You go to, oh, I got to delete that. Go to my template. I want a 2 by 4. And I put in my numbers just like I would, not a 2 by 4. We want a 3 by 4. Put in my numbers. So again, it's important that you double check your numbers. If you're putting them in wrong, no one's going to be able to tell until I grade it, or you look at your neighbors and it's completely different. Again, we're storing it in here. The control var will give us a little arrow. We'll store it in C. Menu, statistics, stat tests, chi-squared two-way tests, Same information we got before. Again, let's check our expected counts. They're all definitely way over 5. So, yes, we can check that off. Chi-squared is 224.116. P-value is approximately 0. Do not put equal 0 because it's not, but it's pretty much 0. And 0 is less than 0.05, so we reject the null. So we have sufficient evidence to reject the null, ergo we can support the claim that marital status and happiness are not independent based on our sample at alpha equals 0.05. Again, just went with our alternate hypothesis. So it's run the exact same way as test of homogeneity. It's just one group that gave us all this data, and a lot of the times it'll tell you that things are independent.